First of all, good morning, everyone. Thank you for joining here. Takes a real dedication after last night party to come here. And luckily, at this time, I have asked for a 10:30 slot, not an 8 a.m. one, so at least I have more people join in, because it becomes very difficult for early morning, right? Thank you so much again. This session is it's about how to start an automation strategy, or for a company or an organization which is just embarking this piece, right? Just a couple of big points here. So this is a 2000 series session, which is essentially intermediate level. So not too deep in the technology, but more of a conversational, just giving you an idea of how other organizations have done it. There are some use cases and everything around it, and we will discuss a little bit more to it. Let's get the logistics out of the way. We have a WebEx room for each of the sessions, as you have seen for this whole week of Cisco Live. Feel free to join, ask questions there. And even though it says here the WebEx spaces are going to be monitored until June 13th, I am still in the WebEx spaces from 2020 onwards. So 2025, even past, I never get out of them. So if you have any questions anytime, join in, feel free to ask. Love to connect and things like that. So who am I? I'm Dhrumil Prajapati. I'm a principal architect within Cisco's Global Enterprise segment, or GES segment. And I lead a team of network architects, which are specialized in multiple different technologies as SMEs. And my role right now is to design a lot of this multi-domain networks and infrastructure, and also build automation on top of that. So this has been my focus over the past few years a lot, especially the automation part of it. I have authored 3 books. The first one is actually free. You can download an ebook. The other 2 are available in Cisco Press. But this is, again, it just shows the amount of work which we have done in the Cisco as a whole with my team, and all the lessons learned which I have there. It's going to be presented here today as well. So let's go over this quick agenda. And before we go and deep dive, one other thing I also want to mention is kind of a good news for most of you as well. This session was originally scheduled for 60 minutes, but they gave me a 90-minute slot. So, it's going to be a lot of time for Q&As, right? So feel free to ask questions if you have. So let's make this interactive. If we're all done early, it's a bonus for us. We can go out and have some fun. I won't hold you up on that, but that's what we're going to cover. So from agenda perspective, we're going to look at, why do we need automation in the first place? What's wrong with our decades-old work of doing point-clicking configuration and things like that? Why do we need automation, right? Everyone has a new name about their own things. I thought I will give my Dhrumil's theory as well about some other topics, so we'll discuss briefly on that one too. Some of the requirements, what is required to have that automation architecture built for your own enterprise or organization. How do you achieve that? So we're going to look at the strategy. One of the key aspects is we do all this hard work. How do we measure success? How we let our leadership know that what we are doing is right? And what are the stepping stones to measure success and get the end state which we are looking for? And Cisco's automation adoption. So we're going to look at about 7 use cases from our customers within the Americas region and which are multinational customers, public sector, and all of those different parts. And we'll show you how automation and net as code and service as a code piece have helped our customers achieve that journey. And we'll close it out with some key takeaways on that one. So the big question, why automation? When you look at this picture, what does this signify? Any quick one-word answers? Complexity, yes, that's one. Robots, yes. Yes. So the way you're looking at this is when a vehicle has been built, basically this is an assembly line. The tasks which are repeatable and which needs to be done on a daily basis, at today's day and age, we want to automate them as much as possible to gain the efficiency which we are looking at. We're not looking at replacing humans with automation and getting rid of the jobs. That's some of the most misconceptions we have. Because right now, the amount of customers I'm working with and having conversations with, The amount of backlog of projects they have, which they want to do, they just can't because they are still having the old processes in place, which is just not able to move them fast enough. Like, no session in Cisco Live goes without talking about AI, right? How fast AI is evolving, it is where we're just not able to catch up that fast enough. That's why we need to start having automation in the places where the repeatable tasks are getting done, right? So when you look at the automation, which is a collection of repeatable tasks, I'll give you a simple example. When you want to do an interface configuration, this is all manual and CLI-based process, that could be done within two places. It could be done in an SVI, which, again, you can create a VLAN, you have to assign VLANs to the thing, or you can do a physical interface where you do a layer 3 routed IPs, where you assign IPs, or layer 2 switched, assign VLANs, or a port channel. And keep on doing that over and over again. So as you can see, assigning VLANs is common. Assigning IP addresses is common in some places. Layer 3 is common somewhere, right? What's changing is some of the context. So building the configuration sets, which is highly modular and reusable, this is where the automation comes and shines, right? This is just one example. So for repeatable tasks, we need high performance. We don't want an automation to take hours to do a task, otherwise we could just do it ourselves. We need high accuracy. Who is a big fan of failed maintenance windows? Right? No one. And I know because I've been on some other maintenance windows which can last for hours. One of my longest one is 48 hours because something really bad happened where some person dig a hole in the construction site, tore apart 75 fiber strands, and next thing we are splicing and doing all this maintenance windows, right? Accuracy is also required because to deploy a network which is 100% accurate to your intent and it's consistent across all the infrastructure, when a disaster happens which is out of your control, it should be resilient enough to fail to your own expectations, right? That's where accuracy comes in. And whenever you're using automation, the decisions are low because automation implies that there is some sort of a structure and logic in place which makes a decision for you and keep on continuing to work, right? When you look at the picture of a car being built, the door's going to go in one place. It's not going to go anywhere else. So there's no decision to be made. The robot's going to come in, put the door in, put the bolts, and it's just going to keep on going, right? That's the idea. Modularity. If you looked at the assigning VLANs part, the same module repeated 3 times in 3 different conditions. How can we reuse one module over and over again without creating large piece of complex code? So modularity and reusability is very key thing. And all of that requires structured data. Now, I would love to know how many of you have up-to-date drawings of your entire network infrastructure ready to go right now, where you know exactly how your network works? Very few. You're doing amazing work because not a lot of customers and organizations have that because things are constantly changing. People put in a change window, they make some changes, and they just don't worry about documenting it, or they assume the ServiceNow ticket they create will document something for them, but doesn't usually happen. It stays in some form of a database, but not readily accessible. And for use of AI, if any organization is embarking on an AI journey, what does AI need? Structured data. So building your entire network infrastructure into a common structured enclave gives AI a ready-to-made food which it can digest and gives you all the insight which is going to give it to you, right? So all the announcements you saw about Cisco IQ, cloud control, all of those things are essentially relying on collecting data from the devices in some sort of a structured format so it can parse and be more knowledgeable and give you the desired input which you're looking at. So those are some of the key things which you're looking at, right? So let's look at Drumil's theory. I'm going to start displaying a picture. Let me, it slowly is going to kind of bleed into a full picture, right? Think about how long it takes for you to determine, in terms of seconds, to know what exactly that picture is, okay? So we're going to start. And So picture's building up. I'm looking at the counter. 15 seconds. Yep. So out of the 30-second clip I had, around 15 seconds, it started to make something clear. The first guess was around that time. Now, what happens when you look at this picture? Mostly sometimes some of you may be feeling hungry, especially if you're from East Coast, like myself, because it's already past lunch hour, right? So when you look at the AI, and when you look at this image of a burger, right? AI is, from my perspective, is mainly used for making decisions and some smart tasks. You can feel free to use same AIs and skills to run automation tasks, but the token usage is going to be exponential because it's going to start consuming that. If you have used Claude Code, what happens is when you start doing some sort of a task, one of the first things it tries to do is to create some sort of a script which it can execute over and over again. That's what the automation is. So what I'm trying to say is, sorry, I'm going to go back one slide. So when you look at this image, the AI piece where it comes down to is when you hold the burger in your hand and you make a decision in your head that I want to eat this, that's the AI part. You take a bite, you chew it, you digest it, all of that is fully automation. Your body knows what needs to be done once after that piece comes in, right? So think about that perspective. Any key decisions you want to make, if something happens, how do you want to execute this change? If there's a convergence or a link outage somewhere, AI can help you make a decision based on what it knows on, okay, this is a fix for this particular issue. But the execution is essentially an automation in the back end. And for that to work, having structured data is very, very critical on that one, right? So this is where all that piece comes into place. So let's look at the difference between AI and automation. So when you look at AI, essentially it's about making decisions, analyzing the data and the patterns and how everything kind of ties into place. Observe the real-time traffic, it can do that as well. And it can look at certain scenarios. It can say, hey, I used to work in an ISP a long time ago, and this was back when the FIFA starts, playing football starts. You can see the internet traffic just suddenly starts spiking up, right? And if this is during business hours, you want to make sure that your customers who are paying business services for their internet connections, they are getting priority and not getting bogged down by some of the other traffic. So those are the patterns which we can track and look and then kind of make decisions around that. This is just back to the burger theory, like I want to eat this burger. That's the decision which you're making. That's where the AI comes into place. And automation is essentially a collection of repeatable tasks. This task can be executed by AI or human, where decisions are being made. Now this is the next step to go forward. And depending on the task, it can execute indefinitely. Like you can have an automation which says, monitor certain time, certain things, make a change, and then kind of repeat over and over again and analyze, right? So if you're doing a backup in the night, it can change QoS policies in the night so that it's more favorable to the backups when production traffic is low. And then when the morning hits in, it will revert back to the other one as well. So this is what the major difference between AI and automation is, right? So for AI to work, automation strategy is very critical. Last thing you want to do is, have AI make a decision on a network which sometimes you yourself even may not be 100% clear about. Because if there's someone pushes a wrong command on a wrong state, without knowledge, it just creates even more outages, right? So this is something which you want to make sure that is taken care of. So going to the requirements, what do we require to have a successful automation strategy, right? So from foundation of structured data is most critical. As I mentioned earlier, we have customers where we have such a massive infrastructure. The controllers today are making life a little bit easier because like a Catalyst Center or Epic or NDFC or even SD-WAN Manager, they do manage large set of data and devices, right? So when the data collection happens, you can still get you can run an API call, you can get a lot of structured data out there, right? But how about cross-relating on multi-domain? Because this session is about multi-domain. How do you want to make sure that if you want to pass an intent on SD access side of things, how will it translate back down to the SD-WAN and to the other side, right? We want to make sure there's consistency across. What changes needs to be made, what BGP peerings or VRFs, or even IP addressing we need to give, right? So those are some of the things which we need to make sure. Continuous integration and CI/CD pipelines, that is something which can be done. I see some of the folks here who were in my lab yesterday. We were just trying to play an experiment with CI/CD pipelines, right? You can do all the automation manually as well. Manually meaning it's kind of counterproductive, but you can execute certain scripts by one command and let the automation take care of everything else behind the scenes. But to take it a step further, you can essentially tie everything into a CI/CD pipeline, which can do everything for you. When you talk about CI/CD, it's continuous integration, continuous deployment, which means every time a change has been done, you go through some set of rules. You do validate the data first, make sure that the data is 100% accurate. No misconfig can push into the production environment. Then you run a planning stage, which is essentially a pre-change process to see the data you're trying to push, is it going to push successfully or going to have some errors? Then you go to the deploy, which is making sure everything is good, right? Like the deployment is successful. Now, when it comes down to trusting someone, the zero trust capability, yes, automation did all, it will give you a green light, hey, everything is good. I did my job, automation is successful. Now, how do you validate that? How do you make sure that the intent was actually pushed to the end device? Because the end device might be managed by a Catalyst Center, and that is managed by some sort of an automation tool. There are too many devices in the middle. So we run test cases which bypass the entire automation process and say, you know what, let me see the intent I pushed was in this particular YAML file, and the end state on the device which I got from an API call is here. I'm just going to do a diff and see if everything matches, if all of my test cases are passed. If we looked into that car building process picture, right? Someone mentioned about robots. We use robot test cases. And that robot test cases are essentially very low processing power test cases, which essentially goes in, does a quick compare, pass or fail. So this is our pre-checks and post-checks. Make sure this is exactly what your intent was. So making sure it's double and triple check that everything is validated, right? And it can all be done with CI/CD. So you can just execute something, go take a break or work on something else while this pipeline gets executed. It will give you a result, and that becomes your essentially end state result. The biggest challenge which we are facing in today's organizations is adoption of net DevOps mentality. I'm a hardcore CLI person. I've been doing this for years. And the moment when they were asked me to say, hey, can you just start doing automation? It's like, okay, how much do I trust it? It's like, telling someone who is a petrol head driving, 60s and 70s, nice muscle car, say, hey, tomorrow you're going to be doing in a full self-driving Tesla, and you just rely on that. It scares it scares people, right? And sometimes, especially when you are going from too much analog to fully automated. So that mindset change is very crucial. How do you achieve that mindset? Making sure you're doing it in the right way. Discipline. Network engineers, we love to, there's a saying, there's nothing temporary in networking. If someone says, I'm going to put this cable temporarily here, we'll come back and fix it, all of you are laughing, right? Even my home is like that. I say, I'm going to move this tomorrow, clean up the wiring. It never happens. So, discipline is very important. And good thing is that can also be automated. Because what we are doing with, from the automation perspective is, remember I talked to you about structured data. When you look at the structured data, what can you do with the structured data? Not only you can deploy the entire infrastructure, you can build network drawings out of it. You can build your entire low-level designs out of it, because it's already there. If you have a mindset of building the entire design in a structured data, that's your single source of truth. How you can use that data to analyze certain things becomes so much easier for you, right? So from Cisco's or even my CX perspective, every project which we are dealing with right now is fully automated in terms of how we are delivering documents. We are designing networks in YAML files, and then it generates the documents automatically based on the YAML, gives you all the information you need, and also it helps us because validate everything. You can take those YAML files, put it in a lab, digital twin, test it out. If everything is good, you put it in the production, run into production change. So single source of truth is very much important. Governance is another key thing. We can establish our processes all day long. We need to make sure that that governance is there, to make sure no one's kind of deviating away. One of the biggest challenges I'm facing is customers asking, how are you going to make sure that my operations guy doesn't go in and configure something on the device directly via CLI if we do as code based, because now Terraform and the automation tools, they maintain state. How do we make sure that the drift doesn't occur? Well, the answer is simple. Remove their privilege 15 access, give them privilege 13 so they can only do read-only operations for now. And when some major issue occurs, you can obviously elevate their access during P1 outages or something like that, but sticking to an as code pipeline just gives them this capabilities, right? So from skills perspective, what we have tried to do from Cisco side is we want to make it as friendly to the network engineers as possible. Now, I'll tell you funny. I took networking because I didn't want to do programming in the first place. 15 years down the line, now I'm doing automation, right? But the challenges which we have is we are so much prone to CLI, and writing these Python codes or Terraform modules and things like that can be intimidating to a networking engineer because that's not their primary job. So what we have done is we took it down to such a bare minimum level where we are looking at just Git, understanding YAML, which is the most human-friendly, readable data structure, files system, and also just simple operations. There is no scripting, no other set of coding required with the open source NetS code tools we have, right? And that is what exactly we want to give, because in the end, you design something in a single format, source of truth, let the automation in the back end take care of everything. And it's good to understand the working knowledge of the other orchestrations which happen in the back end, like Terraform or Ansible, because that's what drives the actual automation, but that is what exactly we are going to look at, right? And labs. So what we have done is we have been able to virtualize almost every single platform we have, which you can virtualize in CML or any other virtualization engine which you can run, and can run all the automation tools and scripts directly on there. Not every organization has a massive budget for labs. It becomes much easier to just have some sort of virtualization lab to test your theory against, at least in the beginning, because you're still learning automation, and this will help you kind of solidify that knowledge before you start doing direct production changes, right? And last thing is testing. You want to make sure that all the testing is 100% solid, because without testing, there's no such something called a successful deployment. Even if it's if you think that this failover is going to work, that's not 100% accurate until the testing is done and actually done the failover testing itself. Right? Any questions? Yes, sir.
Related to the programmability skill set development, which is making network engineers learn programming, programmers to learn network visual.
Yeah. So what I have experienced, the question is which one is better, which part we are going. So are we taking network engineers, building them into programmers, or programmers into network engineers? My experience is very difficult to teach programmers what an IP address and how the routing works. I rather learn bare minimum to automate certain things myself, especially with the help of some of the AI tools, which you can just kind of have a conversation and build something which is more stable than crossing the bridge other way around. Because you're not going to get, if you ask for a yellow school bus, you're going to get a pink school bus from that side. So that's up for debate. But yeah, it's easy to learn from our side, a little bit of tools which can get you going, than to have a whole full stack development side. Yes, sir.
In my experience, my company went through the same journey,
Mm-hmm.
and we tried both, software developers,
Yeah.
or engineering, and vice versa. It's definitely better network engineers because they actually have the context of what we're trying to.
Correct. Yeah.
Just
It's like, the question is, about how do we know? So to your point, having a context of what you're doing is essentially if you are the end, you can't, I would say, I'm trying to find a better analogy on this one, but yes, to your point, having a context of what the end state you're trying to do, if it's a networking domain, let network engineers do it. If it's in a software stack world, then network engineer to learn programming is not going to be a good idea. Let the programmers do their own work, right? There's going to be a little bit of an overlap over time to understand what's happening in the back end. Yes.
The other biggest challenge which we are facing is adoptions, that mentality and
Yeah.
adoptions. Engineers always like to do one command line and something. Is that the only way we can just take out there?
So sometimes, very good questions. The questions about adoption, how do you increase adoption within network engineers? Because they always kind of fall back to CLI all the time. My example in my team, I have a team of around 160 engineers and architects. So we try slowly, hey, this is a new thing we're going to do, start doing it. 10% of them go to the part, other to 90% realize, say, I'm fine, I'm doing what it is. It's not mandated, why should I do it? Then slowly when you start doing mandate, coming down to it, right? But to get to the adoption faster, your leadership needs to be on the same page as your objective, right? The biggest resistance I have found is the network engineers, but not the leaders. But if they see the value and they start pushing down, then that becomes a mandate. Hey, this is the way you're going to do it. This is our new security policy or operational policy. Start going with that method, So this way they can start educating themselves. As I said, there is no such thing as temporary networking. If we are plugging in a cable temporarily or assuming that we're going to come and fix it next day, it's going to be the same thing. We say, if I'm going to learn Python tomorrow, it's not going to happen because we're going to push it out as much as we can. I think we are one of the biggest procrastinators we can ever find. So, cool. So let's go on the strategy. So let's look at how we're going to go ahead and adopt automation on this one, right? So let's look at the levels of automation. Manual work, which you do, CLI, push something, config T, start typing commands. That's a manual automation, right? Then there's an assistant automation. You may have some level of a script or like a VS code, which you can just copy paste and just kind of leverage some preempt prompts, like very low level of automation, which can get you to the config which you're building, or some level of templates which you have and you're reusing with a script to make it generate something different, right? Then you have a partial automation. Partial automation is something where you're leveraging some sort of Ansible playbooks or templating to generate large set of configurations. But the end execution is still manual, copying, pasting, or sending via some sort of a file transfer and things like that. Intelligent automation. So this is where AI assisted, or you will say CI/CD pipeline is kind of that intelligent automation. Because the reason why I say that in this scenario is if CI/CD pipeline starts running, the moment you push a configuration or into a Git repository, first thing it does is a validation of data. The validation is not right if you put in a wrong information. Like, if you have seen some of I can't name the movie because it's recorded here. If you've seen some of the movies where they see the hackers typing in an IP address of 300 dot something, it's like, good luck accessing that, right? It's just never going to work. So if you put some wrong data or information, and if that data is incorrect, the validation is going to fail. Until you fix that, the other stages are not going to execute. That's the idea. That's where the intelligent automation comes into play. That's where the CI/CD pipeline comes into play, right? So you're not missing out on any steps. Steps are predefined. And same thing it goes with the planning stage. If planning fails, if there's some packages which are missing or there's a duplicate of, the data might be right, but there might be some overlap configuration on the controller which may conflict with the intent which you're trying to push. So when the validation and the planning stage occurs, it will say, hey, you know what, hey, you already have something configured here, you are trying to configure something else here. It's not supported. You need to remove the old stuff first before you put in the new one, right? This is why the intelligent automation comes into play. Last thing is full automation. This is where you look at the full stack of leveraging AI, making decisions, making corrections, and things like that. So if you were in some of the keynotes, like especially the one yesterday, they talked about this is a fix. They were I think Chitu was showing during the WebEx board setup. It said there is some sort of an error in the configuration of a switch. This is what the analysis has found out. Do you want to fix it? So it's doing the troubleshooting for you, giving you the recommendation of the fix. And if you look at the analysis, everything is good. That's where the human in the loop comes in, and then you approve it. That's good. Now, that also the key thing which I was interesting on that time is it gives you an option. If something like this occurs in the future, do you want me to automatically fix it? And they checked off yes, and then you submit it. So now you have taken any human inputs out of the equation completely. That's where full automation comes into play, right? So decisions are made by AI based on certain triggers. The fixes are done by AI based on pre-approved parameters and decisions, and it automatically gets fixed. And that's called self-healing of the networks, right? So when you look at it, essentially the leftmost part is the highest human input. The more right you go is the lowest amount of human input which is required. Right? So that's the level of automation. Any questions? Cool. So having a strong lab strategy is good because labs can save tons and tons of time. We have had an issues with, when you look at one of the foundations on why we need, let me just build this slide up. So the reason for having lab and the amount of time it saves in our deployment is so much good because our team as well is embracing this automation journey. And before we start giving you recommendations on this design and how this thing is going to work, how we're going to scale this, we want to test it out ourselves. So even though we make hardware, we just can't have our entire data centers filled with all the lab gear, so we have to revert back down to the virtualization. And spinning up virtual labs is even automated for us. So we can say, hey, I want to build an SD-WAN lab with this many edge nodes, this is the OS code and everything. Come back after 15 minutes, the pod's set up in CML, we can start testing with as code, and it just makes our stuff much faster, right? So this is something which you can do as well. As part of your CI/CD pipeline, you can have a task in the pipeline or a stage which can spin up an on-demand lab, look at the latest state of your Terraform, deploy it, and then put the new one, make sure everything works, run all the test case, will tell you, hey, everything is good. Now it's ready to go and deploy into production. And then you can queue it in the change control window, so when the change control window occurs, it can automatically go and deploy as well. Right? So lab is one of the most critical piece. So measure twice, cut once. Always remember that. Next thing is the strong version control strategy. Everyone knows this little dude over here, right? It's a Git repository, right? GitHub, which we use. So version control is required for maintaining a single source of truth. For NetS code or any automation solutions, you want to make sure that the version control is it's so much easier to even revert the entire change automatically when you have an entire design in that data model structured data. And but this is not the only single source of truth. There may be multiple sources of truth, but as long as for that specific domain, you're relying on a single location, that is good. With our automation tools, some organizations may use NetBox or Notabot or something like that, right? So that can be the source of truth because maybe it's easy for engineers to build and populate data in there. We can run API calls, bring all the data in, and sync it with the Git repo. So engineers don't even have to write YAML files at that point, right? So that can also be done. So, but as long as it's in some sort of a good version control system which can easily revert back, that's the most important part. So all the data model files, which is YAML, the CI files, which is how the pipeline gets executed, the providers or Ansible, whatever playbooks you are running, or all that thing is in some shape or form in a Git repository, because having that versioning and tagging is very important. Git is it's an open source, right? So by Linux, by default, has Git. GitHub is a kind of a social, it's another organization which took Git, made it more accessible with UI. GitLab is another one, Bitbucket. They're all using the same principles of Git in the backend. And so good thing about having Git, and if you want to adopt any of our Cisco's automation solutions, if you already have your own Git strategy in place, Most likely you would, because if you have a DevOps team or doing some sort of cloud presence, they will have that. You can use the same infrastructure. You don't have to have a separate Git of your own as a network team or organization. There's no additional investment required. It's just additional set of repositories, maybe an organization to collect all of your repositories, but it can be done. Right? So pipelines, what do they mean? So again, you don't want to recreate something from scratch, because that's, again, the whole key about automation is reusability. If your DevOps team or Cloud Ops team has some sort of pipeline strategy built in, leverage that. And that just most easier way, because in the end what happens is pipeline configuration, that logic of what steps execute, how they get executed, it's usually a one-time task. So once you build it, test it, give it to them, they will go ahead and start deploying it, right? Other alternatives from the pipelines, what kind of tools do we have? There are some which are open source, there are some which are paid version, enterprise version. Everything has each other's counterparts. So some of the common names are Jenkins, one of the largest one used, Circle CI, Azure, GitHub Actions, and also GitLab, Bitbucket, all those things have their own version of some sort of a pipeline execution engine. And let's say if you want to start doing network as code automation for your team and you don't have anything, you want to be a complete sandbox environment, we also provide a VM which has everything built in, put it in your lab and try it. So you don't have to start asking for resources until you're 100% ready. Hey, this is what my strategy is going to look like. I tested it, everything. Now I want to expand this to a production level. Okay? So that's some of the key piece on the pipelines. Any questions up to this point? Yes. So the question is, if you're using Notabot or NetBox as our source of truth, and if we are using that itself as an automation engine, which one would I prefer over Ansible or Terraform? You can use it. It's not an issue at all. I'll come down to the very high level about perspective is, Notabot provides all this UI capability with automation context built into it. But if you want to do a large-scale environment, if you have different controls like a Catalyst Center, SD-WAN, ACI, and all of those things, and you still want to manage that large data, Notabot may not scale effectively. Second thing is, from vendor perspective, each vendor, Cisco or Arista, whichever you think, they all have their own tools and data models and structures which we provide. And if some automation fails, there is a support for each of the respective vendors for that data model, not the Notabot ones, right? So it's like, like Meraki versus configuring Catalyst 9K on your own by default, right? You get more granularity with the vendor's products versus Notabot. Not that I'm saying we cannot do it. But what happens is most of our organizations use Notabot for data storage and from user perspective, but the automation is executed by vendors' own tools, respective tools. Yeah. So we have something called NAC API. I will show it to you in a minute. Which essentially calls Notabot, captures all the data, and then builds our own automation, like leverages that to use it. So the integration capabilities are there. So now, how would you organize the repositories? When you look at the Git repositories, you already created one. Now let's start working on it, right? So Cisco has all these different solutions, ACI, SD-WAN, Catalyst Center, ICE, FMC, Umbrella, Thousand Eyes, you name it, right? iOS XE, XR, and XOS. How would you do it? Would you just make it everything into one giant flat file? Or do you want to do it per technology, or how do you want to distribute it? So usually it's, if you do one repository per product or a solution, it just becomes so much simple for access, because all of your campus data is in one location, all of your data center data is in another location, and because usually the different teams maintain those domains, it's also easy to control access to those data. There's also a use case where you do a mono repository, where you have everything in one place, which is good because if you are doing a lot of multi-domain changes, it is also easy to just kind of tag along all of them in the same time. But most of our customers rely on the first block, which is per product or solution. Usually our role, thought process is if if you have multiple Catalyst centers or multiple ACI pods, they will do per pod repository. So this way, the blast radius or whatever you think about the management domain is very limited on that sense. When you're branching out the repository, now we are going deeper into the repository itself. Let's say you want to make a change. How would you make it? So what we typically do is you can work on a mainline branch, which is simpler way. It's good for labs, not good for production because you don't want to just push everything to main repo anyways. What we usually typically do is feature it and merge it afterwards. So this gives you a lot more benefits, right? So if you have one main master repository which is protected, so don't want to get auto merge everything, it has to be reviewed and approved by an architect to make sure the changes are good. If I want to make a change and my peer wants to make a change, I will create a branch out of that, make my change. He does the same thing over there. And then we respectfully merge our own changes into the main pipeline. And the reviewer approves it, and based on the merge and the data, we then essentially just go in and merge into the main pipeline when the change gets executed. And this is crucial because you want to, again, limit the conflicts between different things. If I'm creating a new VLAN on line 20 of one file, that person is creating something else, you want to make sure that the changes are essentially merged, without any issues, right? To be honest, as a network engineer, my biggest fear when I started doing automation was whenever the merge conflicts occur. It's like I had no idea what I'm doing here, right, at that point, because it's very scary. But once you start doing this process, you get used to it. You know what exactly changes are being merged. It becomes a lot more simplified. And last thing is a feature branch to the development piece. So this is pretty crucial. So this is how we develop iOS XE from images as well. You see, there's a main release, which is mainline deployment or MD release from iOS XE. Then you will see different sub-releases come up over time. And those are essentially bug fixes, right? And sometimes what happens is, let's say you have an entire campus SDA network already deployed, tested, production, good to go. You're doing daily changes. But you have a new initiative where you want to start deploying multicast in that entire environment. Now that's not an overnight change you're going to do. You're going to try out different things, settings, test, validate. So you would create a fork of that branch, which is production. You do all of your changing and testing, then you find out what exactly the final solution is, and then you merge that into the main branch. That's part of a final push, right? This is why this particular piece comes into place. And that ties into the release strategy. Now, these are all a lot of DevOps terms. For network engineers, again, may not seem very familiar, but this is something which we end up using on as part of the new norm, right? So you can do release directly on the main line, which means you merge all the changes directly. If a lot of the labs which you have seen here on as code, that's what you are doing. You are just directly pushing into the main branch. That's it, good for labs. And then you can do a release and a tag. Tag is pretty crucial. Let's say if you have a 5 or plus or more than one Catalyst Center deployments across your entire infrastructure. If something works for one cluster, you may not be ready to deploy the second cluster, but you want to use the same consistent data models and policies. So when you release certain things, you release it with a tag. And that tag signifies that I want to use this tag code as my baseline, and I want to start from there. So this way, this is your golden image, golden configuration, which is always there. And as you do some more testing, you can change tags. And the moment you change tags in other places, you automatically sync with the data and then start pushing changes out automatically, right? So tagging is something which is also can be done. And just like everything else, you can also mix and match, right? You can do option 1, which is mono repository, option 2, per solution or a branch, and separate solutions. So these are some of the common pieces. Now, going to the orchestration, the big debate about which one's better, Terraform or Ansible. So let's look at Terraform and let's look at the differences and why Cisco has made a de facto strategy to use Terraform going forward and not on the Ansible side. If you look at both of the solutions, they are orchestrators. There's a massive amount of overlap on what they both do. But the difference which comes in how Terraform and Ansible operate in the backend is something which is what the defining factor is. Terraform is declarative. You define an end state, that this is what my end state looks like, and we'll make sure that the end state always is there. And that is done by maintaining state file, which Ansible doesn't, right? It's an immutable infrastructure, which means you can't just go ahead and start making random changes because Terraform is not going to allow you that. And that's good, because last thing you want is last-minute changes on the infrastructure and create more outage, right? Terraform was built to deploy large cloud infrastructures, spin up multiple servers, multiple containers, everything at a very large scale. So it has scale component built into it. Ansible is more of a configuration and procedural tool, right? So, hey, this is my logic of the task I want to do in sequence, just go ahead and do it, and that's it, done. There's no such built-in validation capabilities inside Ansible itself, right? So there's always this is where it comes down to planning and apply of Terraform. Planning is to show you what it's going to look like. Apply is when it actually goes ahead and deploys in Terraform, right? It is a steeper learning curve. If you look at the negatives of it, that's why a lot of people say, I know how to use Ansible. Can I just not use it? Yes, you can. But when you look at scale, this is where the big factor comes in. And state file challenges, and the reason why I'm saying state file challenges is, a few minutes earlier I talked about engineer goes in, you have everything managed by Terraform, there's a state which is built in. Engineer goes in and configures something on Catalyst Center or on a device. Now Terraform state is out of sync. Now someone else configures something and pushes the commit through. Terraform thinks this is my existing state, it's valid. It's going to add new stuff to it and going to push it. The moment it sees there is a discrepancy that someone else made a different change, it's going to override it because Terraform thinks what I have is my final state. So it's supposed to be a source of truth. That's why I was saying, having a discipline is very important on how you are executing those changes, right? But that is the beauty of Terraform, because then this way you can maintain an entire network into a single state, which can be essentially a big giant JSON file at that point. Looking at the Ansible side of things, it's agentless, ease of use. You can start writing it. There's no major stuff required from the infrastructure perspective. Procedural logic, if you want to do a migration, you will just say, log into the switch, back up the configs, save it into this file, push this config template, log out, do the same running test again, make sure everything is okay, save the config, and then back out. That's logic you're doing, but you're defining that every single time. If a change is a little bit different, you have to go back, change the playbooks to make it even more subjective. With Terraform, all the logic is built into it. There's something called dependency tree on Terraform. So the modules we write has dependency mapping built into the Terraform code itself. So you can say, I want to put a VRF, and in this interface on a VRF, then what happens is, let's say if you forgot to create a VRF in the first place, but you put a VRF ID on the interface and an IP address. So now when you run Terraform plan's going to say, hold on a second, you want to put a VRF on an interface, but you don't have VRF defined globally. You need to fix that first before I can even go ahead and do it. In Ansible, that logic may not be there. It will just go ahead and start creating an interface VRF, but the VRF doesn't exist. XC may throw an error, but then we'll just ignore it, right? Even when it goes down to the removal of certain artifacts, it goes in the exact same opposite way as well, in the reverse way. It'll remove the dependency trees first with the leaves, and then slowly goes down to the top of the hierarchy. And the good thing about Ansible is, if there is no dependency and the task can be run parallel, it will run parallel. So it will be multi-threaded at that point. Cool. So let's look at the best practices to employ and what typically we look at, right? So just kind of recapping on what we have done so far from the strategy and automation perspective. Recommendation is always use version control, like Git, get into a habit of that. Whatever you do, you can even your normal files can be a version control on your laptops, in that case. Always use the build machine. Let's say build machine is essentially, if you're trying to push some changes across, what we do, and this is where you can get an idea from, right? Every time we build the net as code modules or the data for the Terraform modules perspective, and all of that is built by network engineers like myself, right? We have something running called a build machine, which is a 24 hours, there's an iOS XE or some other device which is running, and every 24 hours, the configurations which have been committed over the day, they get pushed and get validated again. So if something breaks the next day, we know that the change which was pushed last night was a broken one. So our troubleshooting becomes a lot more easier. So whatever solutions comes out to you to consume from the Terraform modules perspective is essentially tested every single night from our side of things, right? That's how the build machine is. It's just running something every single night, making sure that the code is still good and there's no major issues with it. So avoid working on a main line. So if you have a large infrastructure, obviously for the productions, it's a big no. You protect the mainline branch, or the main branch, or a master branch in your Git all the time. Only have a certified 1 or 2 reviewers, making sure that changes good before they merge everything into it. Never commit passwords to the Git. If you are using GitLab, there's a variable section where you can put all the variables, put it in the environment, put it in the vault, whatever you want to do. But never store clear text passwords on the data model itself. Good habits. Try to have a linear commit history, which means you have a production branch, you create a branch, you make a change, you merge it. And keep on doing that instead of forking out multiple things, and now you don't have a single source of truth anymore. So linear history is always good. Good commit messages. If you're changing an interface name or a description, write change interface name or description. Just don't say interface or name change. It just becomes very complex. Nowadays in VS Code or any of the IDEs you use, for the commit with the Git integration, you can just click on the middle stars in the back, and it will say, okay, this is the change you are doing. It's going to summarize what the change you did, and it's going to put in the commit message. You don't even have to do any additional work at that point. Just some of the things, branches for the main and merger to the branch line, which we talked about, strong credential management. You're giving a lot of power to an automation tools. You want to make sure that that credential, the service account, is protected, right? We have some sort of authentication mechanism, right? So this way, no one can misuse it. Build machine, which I already talked about. Always have a manual backup plan. This is something which is, trust but verify kind of things. Until you get into a habit of trusting your entire pipeline, you do it over and over again, then that backup plan may not be required. But sometimes what happens is you may not know that you might be going inline through a main WAN connection, changing something on the WAN router or downstream, and then you lost access because you locked yourself out. So you want to make sure that some of those things are taken care of, right? So initially, always have a backup plan manually. So best practices, it's like how you like your coffee. It's very subjective to each enterprise, so stick to that, whatever you define it as a collective team, but stick to it. That's the most important thing. Just don't, sway away from that. So, any questions before we switch to the automation tools which we have on the side?
So maybe the first slide maybe related to this golden run, the standardization. Before starting automation, we see a lot of challenge of doing that with a complex network where it's spread across 160 countries. There are many integration happening, many acquisitions happening. So what would be your recommendation of standardization?
Yeah. Very good question. So, and we're going to talk about it in a moment as well about that. The question is, when you are starting automation journey and you have hundreds of sites spread across the globe, very large network, how would you start? Where would you start it? What is your first step in that sense, right? So my first step in that case, and which I work with my customers, is just do a simple POC. Forget about your network at this point, right? Understand what goes behind the scenes on building the network infrastructure itself using automated. Because once you know, it's just like learning how to drive a car. Before you drive on the highway at 70 miles an hour, you need to know how to turn steering wheel and all those things, right? Start something small, local streets like that. You should start something small, then expand at higher levels. Second thing is when you look at the whole idea about scaling, once you start a location or site which is more clean, because usually what happens is every time you do a transformation or something, you have to do some form of remediation because a lot of old stuff is there. But now we have changed the game further because now what we have happened is, let's say like this Mythos and all of those new things coming out in the market, right? Now we have an ability to ingest entire infrastructure as is, even if it's a lot of garbage configs on it. We ingest it. And once it's in a data model structure, it's so much easier to clean because now you see everything in one place. Then you can say, okay, I don't want this kind of configuration. I want to clean this device. I want to have those things and just execute as part of commit pipelines. So slowly start cleaning everything up as well. So you can do that. But as I said, start something slow and slowly expand as your comfort level grows. From a multi-domain perspective, you can start with one technology domain. Make sure you're fully aware that team is fully able to maintain it on their own. Then switch to the next technology, and then start that into the same process. And you will see right now, because when you look at the challenge, which you just mentioned about, the changes, the culture change itself is in the networking skill gaps, the commitment across the organization. Network team says, hey, I want to do this. Data center says, nope, heck no, I'm okay with what I have. I love my Ansible playbooks. All the Snowflake networks, different sites, different type of designs, ad hoc, organic growth. That's fine. We can ingest everything. But having a good framework is essential. How to get that, right? Failure to adopt this entire automation architecture is also something, making sure that we are aligned with all of these pieces. Excuse me. So let's talk about what the building blocks of this is, right? When you look at network automation architecture, what are the building blocks? So you have a network infrastructure in first place. You have a source of truth, which is usually like some sort of inventory management. In this case, we are also this is just a framework, right? You have an automation engine, could be Ansible, Terraform, Catalyst Center is also an automation engine, Epic, ICE, all of that are doing some sort of orchestration across somewhere. Telemetry and observability, so Catalyst Center's assurance. SD-WAN manages the analytics. You have Umbrella, whatever else is there. It's collecting data, could be Splunk, and just trying to kind of correlate everything together. Then you have a top-level orchestration on top of it. That's the network automation we are talking about, right? And then everything needs to be API/user managed, which means whatever you do needs to be scalable in the sense that if I want to create a ServiceNow ticket, or it should have some sort of a change management going through it and coordinating everything together. So this is a framework of the automation, right? What you're looking at is the ITSM is some sort of ServiceNow, like a ServiceNow-like interface. Dashboards, you want to see how many changes have been pushed, some sort of a data which you can give it to executives. Portal is maybe you may have a digital form. Let's say one of my customers says, you know what, I don't want to take tickets to enable a meeting room port in some building. So they say, perfect, we create a web portal. If someone wants to make a change, and we say, they will say, this is a meeting room, this is a port I want to be enabled, this is a port ID or a tag, and then you just kind of fill out that information, submit it, that goes into a structured data to the ServiceNow instance. We automate the heck out of it, and then we'll say, okay, this is what it comes in, the data model, gets merged into the main line, and then just gets executed. Now, those are so much static. We talk about the full automation in that ladder we were talking about. That's where it comes down to. Some changes are so repeatable that you don't even want a human loop in between because we know that we have safeguards in place. Some of the larger ones, definitely we need humans in there. So switching from this to this is the infrastructure as a code framework, right, on how this thing works. This is what it looks like from the network as code perspective. So the difference you are seeing here is the source of truth from the other one gets moved into the single operating model for us. So that's our GitOps, GitLabs, all the pipeline stuff which we create. So this is the network as code. This is Cisco's commitment to open source, the network automation altogether. So if you go to a site called netascode.cisco.com, that's where you will find all the data model structures and how everything is built, publicly accessible, so you can build your own tool if you want, right? That is something which comes down. So what exactly is in the network as code automation? Source of truth perspective, we use GitLab, GitHub. Default, you can use any kind of Git repositories. CI/CD pipelines, you have different options. Notifications, you can also include chat ops in there. So once the change is successful, you get notified by a WebEx message, MS Teams message, or something like that. You have pre-change validation. So we want to make sure that the changes you're pushing are actually accurate. Automation engine, we have Ansible, Terraform, or OpenTofu. Some of you might have a question about Terraform has some sort of licensing issues, right? You need to pay something to HashiCorp or IBM in cases for the Terraform licenses. All the tooling you see right now from Terraform perspective is compatible with OpenTofu. OpenTofu is a fork of a Terraform, which is open source. So instead of typing command Terraform plan, Terraform apply, you do tofu plan, tofu apply, and things like that. Automated testing, robot, PyATS, right? All the testing is also kind of part of that piece. And the bottom bar you see, regardless of the technology is defined here, could be physical, virtual, or cloud, same framework applies to every single thing. So from operations and management perspective, this becomes so much simple. You don't have to learn different UIs, where to provision certain things, and everything from Catalyst Center or SD-WAN or anything like that. You have everything in same way of managing the entire infrastructure for yourself, right? So coming down, the other piece is the API part as well. So now we are adding more components to it, right? So let's say if you want to go to a next level, there's something called NAC API, Cisco Workflows. That can also be integrated into this, right? So it can talk with external sources like Nortobox or Netbox or Notabot and iTentials. Different organizations have different needs, so you can integrate with that. Splunk and other telemetry tools you may have. This kind of works like that, right? So this is what the NAC API framework looks like. So let's say you have ACI, its automation stack, firewall, its automation stack. You can have an overlaying NAC API, which you can make it UI-based if you want. If you don't like editing YAML files, that's okay. Make it UI-based, configure that, and then you have ServiceNow and user integration on top of it. So think about this way. If you want to put in a change in a ServiceNow request, ServiceNow triggers API calls to these different tools, starts creating the data models, the intent, what you're trying to push, and kind of builds down all the data for you. It's going towards the full automation part of the automation here. And each of this is going to go through the same lab testing as well before it gets pushed down to the other things, right? So this is what a typical pipeline looks like. So I'm not sure if you have been on other sessions where you may have seen the same slide. Basically what happens is, how do you start? The journey which we're talking about, what is the first step? First step is making an assessment. Where do you sit in terms of automation strategy? Then look at the options available to you. Do you want to use your own infrastructure for net DevOps, like your own CI/CD pipelines, Git, and things like that, or do you want to use Cisco's Common Automation Framework? It's completely open, optional. Then come down to the integration requirements. Which other systems you need to make sure that that is available to you. So you may need ServiceNow integration, Netbox, IPAM like Bluecat or any other IPAMs, right? Or Infoblox per se. Let's look at that and start integrating them using NAC API, right? And once that is done, this is where this build part comes into place. So you start and that's the repeatable part, right? That's where the automation piece comes in. Everything here is all one time. This is all the repeatable piece. So tomorrow you want to go in and make a change. You create a change request in ServiceNow. It creates a Git branch for you. You modify your code, which you need to do in the YAML files or data. You merge it. You run some micro tests, which is NAC validate. You merge it into the code commit. Once it's done, additionally, you can do a full testing in a lab, or you can just go directly to the production side, making sure the planning and everything is successful so that someone manually can approve it. Yes, as a network manager or an architect, can approve the changes. It's going to get committed. All the testing is going to be done. Provisioning, archiving of all the test reports is all going to be done, provided to you, and we are back to the starting point. So that's the circle of life for automation. Same thing over and over again, and this is what's going to get you to the full automation journey. And this you can expand down even further to multiple domains, interconnecting multiple domains across multiple sites and regions as well. It's the same process. Yes, sir. Question.
Is there a piece that automates automation of documentation?
Yes.
Typically, we have a project that we need to implement this. We have to do transition to operation. We have to submit the build books, the run books, integration,
Yes.
Documents, interface control documents, all of those, multiple documents, and then there's diagrams that need to be generated as part of this. Where does it
Yes.
all fit in? Can
Yeah.
you automate that?
Yes, absolutely, 100%. So right now we are, as I said, remember earlier I mentioned Cisco is actually using digital documentation now for all of its deliveries, right? Digital documentation generation, right? So basically what happens is every time we build a design or change happens in the design, the structured data is essentially leveraged to build the entire runbooks and migration plans and everything fully automated. So we have templates which are built, which have variables in it, and those variables point to certain context in the data model itself. So the question is if we can automate the entire documentation process with the single data source, and the answer is yes. We have available something today. You can also take the same data, because you have all the interconnection points on where each interface is connected to and everything on each of the repositories, you can build entire network drawings out of it as well. So you can run API calls to draw.io, for example, and then just say, this is my calls, just give me the entire network drawing, I'll give it to you. We use Cisco stencils as well for that piece, right? So every time you push a change or add something new to it, the network drawing is automatically updated behind the scenes as well. Yeah, we have available today. Yeah, absolutely. Cool. Let's move on to the measuring success, and how do you want to make sure that this is correct, right? So team motivation is key. Making sure everyone's geared up to the automation journey. Then this is where the enforcement comes in. We say, okay, now we have moved on to this. Everyone was given X amount of time to learn. Now we're going to start using this on a daily basis. The governance piece, which we talked about infrastructure and infrastructure setup, making sure all of your build pipelines in the lab or in the production are built. Then using automation for smaller tasks, so start smaller sites, smaller pieces, and then expand into a larger enclave. Building pipelines, making sure that these pipelines, you may have a stack of pipelines. There may be a pipeline for just executing ACI, for example, or SD-WAN. There may be a pipeline, which is what I was talking about automatically approving meeting room request kind of a thing, right? So if there's something there, then it will just work that way. So the pipeline comes in. Using automation for a single domain, so this is for like SD-WAN or Catalyst Center, then you start up from operations perspective. That's the idea. Cool, so now let's take a few minutes into the customer testimonials and some of the things on, these are the customers which are within Americas regions and how we have transferred some of their pieces, right? So this is a large retailer, more than 3,000 stores across the US, a big box store, and they have 5 SD-WAN overlays, and they wanted to start converting everything into as-code model, right? So the details of all of this will be available on the slides. I'm not going to read line by line, but I'm going to give you a context so you understand what it is, right? The biggest challenge they faced was, how can I automate my day-to-day change control processes? Because there are changes which are required, maybe interfaces enabled and things like that. And each of the site was like a snowflake for them. So we were able to simulate this entire infrastructure. There's something called brownfield import from Cisco. So what it does is, if you have a network which is already deployed, it will ingest the entire data from that controller and going to convert it into a data model for you. So you don't have to build everything from scratch. And that brownfield import, we put it in a lab. So essentially, we built the lab with exactly the digital twin of the production environment and started running these test cases. The operations teams got enabled, so they know how to use it. And then, once they were comfortable, we did the first overlay configuration, moved it into as code. We ran it for 3 months, so all the changes for that overlay goes through as code. They became comfortable. The 4th month, all the remaining 4 overlays were also onboarded right away. Because now this is the same process for across everything. This helps a lot because one of the key reasons for this was the personnel. Because every time they had to make a change, they had to have people on site to validate certain things. And we replaced them in terms of, you don't have to have people late night just sitting there until network change is done and then verifying certain things. We did so many of the test cases built of that within the pipeline itself, so we don't have to send people overnight during the change windows. And all the change becomes repeatable at that point. And testing becomes part of that team as well. The second thing is the manufacturer. This is another SD-WAN as a code use case, where manufacturer reduces network risk through the high automation, right? So this is where the risk, they had a massive security breach, which resulted in tens of millions of dollars of an outage because of inconsistencies. Network did not converge as expected and things like that. So their biggest thing was, now we want to secure everything, make it fully automated, have everything ties into the process. No random person can go in, make changes. And that's the big transformation for them. And this helped them to release that, because in that we actually tied our net DevOps process to the DevSecOps, which is development and security operations, right? So all of the security changes which they try to push, they tend to merge into the same pipeline as well. So if security team comes in and say, hey, I want to push this firewall rules into this particular router of yours in SD-WAN, they can't just randomly go ahead and push it. They branch it off, they make the changes, they push it in, and then the network team, because they own the infrastructure, they look at it, they approve it, schedule it. So now this becomes more of a collaborative approach between both teams. So this is for the unified branch use case. This customer, its financial entity, had a lot of branches which were essentially organically grown over time. No consistency in deployment, a lot of snowflakes, and we wanted to make sure this is all combined. So last year, Cisco Live, we came up with a unified branch solution from Cisco. It was announced in last Cisco Live. So this was one of our first customer adopters, where we took that, essentially one box, where they had their firewall, the routing, the switching component, everything into it, and we automated out of that using Meraki Cloud as well, right? So this, again, another example of how to standardize entire deployment using automation. So they have a lot of end-of-life gear. They were removing from branch anyways. So instead of doing one-to-one box replacement, we put in this new unified branch box, deployed everything with automation, and now it became so smooth that we just now send the kit to the branch. The branch now goes in and plugs in all the devices, because we have that cheat sheet laid out with the ports and everything. And the moment the device is connected, it triggers plug and play workflow, and then essentially gets onboarded into the automation itself. So it becomes very streamlined. This is another one of the big retailers in the US, multiple ICE clusters. I think they have upwards of 40 plus clusters. It's very massive distributed ICE environment. The challenges they were facing was certificate upgrades, some massive infrastructure management, not the policy part of ICE, but the infrastructure itself. So we use ICE as a code to build fully automated solution where they can do entire infrastructure management, software upgrades on ICE, patch management, certificate updates, policy updates, everything in one shot. And that is essentially done during those maintenance windows, right? So it all happens in a waterfall approach, so that this way there's always resiliency available and essentially giving us zero downtime during the process itself. Now, this one is the next part of that ICE code where we had to convert out of our end-of-life gear into a newer one with the scale as well. So again, migrations, transformations, we're looking at consolidation of the different devices and networks. All those different use cases are over here. And this is the manufacturers reducing downtime. So this is a large factory. It's a battery manufacturing customer. This was one of my customers where we used iOS XE to deploy entire factory's fabric infrastructure, iOS XE as a code. And that was something which was very tremendous because now they are producing EV batteries for I think, and this is one of the largest factories in Kansas right now. Again, same process, CI/CD approach, and this was an Ansible-based solution because they wanted something which is very much user-friendly for their team because they had already hired a team for about 15 engineers which were Ansible experts at that point. So they said, I don't want Terraform, I want Ansible, and that's okay. You know, it's like Mac versus Windows. You can't force someone to do something as long as they know the caveats and they understand the pros and cons of both solutions. That's okay. And they use Ansible route. We build a solution for them, and they're using it today as well. And this is for the ACI. This is one of the customers in the Europe, which had a massive, again, an outage scenario where they lost a whole bunch of revenue and access to the environment, and they ended up going to the service as a code because this was actually in the news over in EMEA. Banking lost access to the environment for a couple of days. And using automation, they started to bring consistency and config drifts in control so that the entire data center is very secure. So, last slide or two. Key takeaways. Automation is a journey. So don't worry about if you're not going at a full pace. Everyone has its own, pace to go at the speed. So it takes some time to adopt. But please, that is the new future of how we're going to do things and how the Cisco is going to do things from delivery as well down the line as well. Whoever is adopting AI strategy, always remember, automation is foundational. Like I said, you can make a decision on eating a burger, but the digestion and everything else is fully automated from your body perspective, so that happens on its own. So automation is key. Working with structured data is important. To your point, you were talking about creating drawings or diagrams. Can all be done. You can ask Claude Code if you have access and say, hey, I have this data, can you build a drawing for me? And we do that as well today. Like if I want to build a quick drawing, say, can you take a Cisco stencils and build a spine leaf topology and something like that, would just speed up something very generic. But yes, you can do it. Imagine if you give a structured data, it can be very detailed in that sense, right? So you can experiment on that as code. So a lot of, our commitment is to be open source as much as possible, right? So you can go to this GitHub, you will see .NET as code, and you will see all the Terraform and all the repositories which are publicly available to use in that sense. Governance is key. You can put all the security policies in place, but if no one's enforcing it, it's not going to go anywhere. So make sure that your leadership is on the same pages and everyone's enforcing it. Test plans, validation. Again, validation is very important. Build up a digital lab, run it through, make sure everything is good, and then you can go ahead and proceed further. Leadership support is very crucial. Many times I have a network architect say, I really love this and what you're doing. We just need to convince our leadership so they can make it a mandate so that all engineers are on the same page. And we have helped them convey the message to the leadership as well. And it helps in that sense. Stick to the plan. That's the most important thing. There's always an itch in the hand that I want to go SSH, CLI, config T, start config things, but stick to the process. It becomes very easy. The more you do it, the more it becomes easier it becomes. And we're always there to help you, right? So whatever else you need in the journey or in the process, Cisco CX can always help to jumpstart that piece as well. So with that, I really appreciate your time and patience. Please complete your session evaluations. And I know this is almost last day, so other slides are pretty much irrelevant at this point. But thank you so much. Really appreciate you being here.